execute. Okay, let's execute our knowledge. We're going to move as fast as we can. I just want us to quickly solve this question. It is not hard. We don't want to waste time on this thing. So we're going to go to the MF19. I'm going to take you to MF19. Sorry for this. I'm going to go to the MF19, show you the integration by parts, the way your MF19 puts it. So we go down, 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 down until we get to integration. There we go. Is it here? Okay, now I've passed it. I'll go up a bit. There we go. Let's see. Further pure mathematics. No, we don't want further pure math. This is integration for pure mathematics. And if you come here, this formula is going to be your by parts formula. Right, so by parts is under the integral. This is what we were calling the common integrals. It's a table, okay, which you're going to have in your exam. There we go. So below that is going to be your by parts. So you go down, 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 down until you see the word integration. Well, that means you're now at the common integral table, and below that, this formula is going to be your by parts. Now, sometimes you see people, maybe you'd have watched a YouTube video and you see them say u dv is equal to uv minus so it's the integral of u dv is equal to uv minus the integral of v du. This is also correct, but I want you to write it this way, okay? This way, and I'm going to show you how you do that. I want you to write it this way, the way your MF19 is putting it. Either way, let's go and let's get to work, okay? Right, I'm going to go to the other thing. There we have it. All right, now we're saying, the question says, find the exact value, blah, blah, blah. We see that this is by parts because it's two things multiplying and we are asked to integrate. We have an algebraic and we have a trig. And they are multiplying, but we've seen that this one is the one which is composite because it is cos of something which is not x. Now, we look inside. Can I differentiate to get this? No, you can't. So they are not related, so we have to use by parts. Now you're going to say, okay, so you're going to now say for integral of x squared cos 1/3 x, okay, with respect to x. We're going to start with this. Now, everybody, obviously, we're going to come back and put these limits. These limits make it a definite integral, okay? The definite integral is just an integral with limits. Without limits like this, it is called an indefinite integral. So we're going to then come back and put the limits. Don't you worry about it. We're starting by working with this part. We just want to work with this part and see how we're going to do it. We want to develop the integration by parts formula. But first of all, there are things we got to do. Integration by parts, let me put it here with a pencil. So you'd have put it, it actually says the integral of u, okay, integral of u dv dx with respect to x. This is the way you would see it in your MF19 is equal to uv minus the integral of v du dx with respect to x. So this is the way it is in your syllabus. Now we actually want to put it, we're going to write it that way, but you don't just start by doing that. What you can see is that there is a part which you're going to call u and there is a part which you're going to call dv in the by parts. So in the other part, there is a part which you're going to call u and there is a part which you're going to call dv dx, okay? dv dx, not just dv, but dv dx. Okay, so there is a part which you call u and there is a part which you're going to call dv dx. Let's go ahead. So what do you call u? You are going to use the word Lie8. So the word Lie8 tells us the types of functions, but it also tells us the order in which to choose u. So it's logarithmic, then inverse trig, then algebraic, then trig, then exponential. So you're going to see, okay, what do I have here? Do I have logarithmic? No, I don't. Do I have inverse trig? No, I don't. Do I have algebraic? Yes, the x squared. So you're going to say, let u be equal to x squared, which automatically means the second thing will be your dv dx, which means that dv dx will be equal to cos 1/3 x. Now you're going to then say du dx. Okay, we have u, that means we can get du. U is in terms of x. That means we can get the derivative of u with respect to x. So that's du dx. What you do is just the power rule. You drop the power to reduce it by 1, so it becomes 2x. Then now, what we are going to do to dv dx is we are going to take the dx to the other side, and we will have dv be equal to cos 1/3 x dx. Then we integrate and we integrate. Okay, so you won't integrate in the same line. You then integrate to say integration of dv is equal to the integration of cos 1/3 x with respect to x. So you're integrating 1 with respect to v, you get a v. This is going to be equal to the integral of cos 1/3 x. Now here you're doing What is this? This is a composite function. Everybody agrees with me that cos 1/3 x is a composite function because it's not a cos x, it's a cos of something which is not x. So it's a composite function. So when you're integrating composite functions, you are going to use what we call the reverse chain rule. And you can see that I added it on the list. There is reverse chain rule on this. Yes, so you're going to use the reverse chain rule. Now, reverse chain rule, when you differentiate composite functions, you use the chain rule. Chain rule is to differentiate things like this. Now, when you're integrating it, you use the reverse chain rule. Chain rule says when you're differentiating, you differentiate the outside first without changing the inside. Okay, you start by differentiating the outside without changing the inside. Then you multiply by the derivative of the inside. That's the chain rule. Differentiate the outside without changing the inside, then multiply by the derivative of the inside. Now, reverse chain rule will actually say integrate the outside, then divide by the derivative of the inside. So you integrate the outside without changing the inside, then you divide by the derivative of the inside. So if we integrate the outside, remember the outside is cos. The inside function is 1/3 x, which is an algebraic. So if we integrate cos, we have to go to our table. To integrate cos, you just go to the table, class, to integrate cos. So let's go to the table. I'm going to go to MF19, back to MF19. I want to see how I integrate cos and how I integrate sine. Those are just important because they come a whole lot of times. So this is our common integrals table, and you can look for cos. If you integrate cos, you get positive sine. If you integrate sine, the positive version, you're going to get the negative version of cos. So in integration, when you integrate sine, you get negative cos. And when you integrate cos, you get positive sine. So, okay, no problem. Now, let's go ahead and let's put that. So, I'm going to say, fine. The integral of cos don't change. So, integral of cos don't change. So, I'm going to say, I'm integrating cos. I'm going to get positive sine. So, it'll be sine 1/3 x, okay? Because you don't change the inside. It's still 1/3 x. But then you divide now by the derivative of that inside. The derivative of 1/3 x is 1/3, okay? Now, dividing by 1/3 is like multiplying by 3. So, it becomes 3 sine 1/3 x. This is for your v. So I have my v, and I have my du, and I have my u, and I have my dv. So that's what you need, everything. This is all you need, and now you can start to use. So now you're going to then write the by parts formula. You're now going to say the by parts says the integration of u dv dx with respect to x is equal to uv minus the integral of v du dx with respect to x, okay? Now, we are just going to substitute those things by putting something. So, what are we going to do now? We are going to say, fine, let's now put it. So, you're going to say, what is u? Is the integral of u dv dx, whatever, you've already chosen it. It's x squared cos 1/3 x dx. So, integral of x squared, which was our u, then times cos 1/3 x, which was our dv dx, with respect to x, is equal to, what do you now do? You say uv. So, uv, let's put uv, I'm going to say this is equal to, now what is my uv? I go and get my u, which is x squared. I multiply by v, which is 3 sine 1/3 x, then minus the integral of v, which is again 3 sine 1/3 x, but this is now multiplying du dx, which is, I come and get it, it is 2x, so it's now multiplying 2x, and this is all with respect to x. So now I say this is actually going to be equal to, I simplify, 3 is a number, it comes in front. So it becomes 3x squared sine 1/3 x minus now the integral of 2 times 3 becomes 6. And then you put the x before the sine 1/3 x, sine 1/3 x. And you're integrating this with respect to x. Now what you're going to see again is that what you have here, sorry for that. You're going to see again that what you have here is, you have another thing like 2 things that are multiplying and you want to integrate again. Now, when 2 things multiply, we said either you use u sub or you're going to use by parts. And for you to check, you're going to check, here is my sine 1/3 x. If I differentiate 1/3 x, will I get the thing here? No, you won't. So they are not related. So we have to use by parts again for this one. So that means you are going to go and do by parts for this one, then come back and put the answer here. So you're going to say, for example, you're going to say for the integral of 6x times sine 1/3 x with respect to x. What are you going to do? You're going to choose your u again using Lie8. Right. Is there logarithmic? No. Is there inverse trig? No. Is there algebraic? Yes. So you're going to say let your u be the 6x. which means that the sine 1/3 x is obviously your dv dx. So dv dx will be equal to sine 1/3 x. Then what am I going to do now? I get my du dx. I differentiate 6x, I get a 6. Then here I'm going to take dx to the other side first. I get dv is sine 1/3 x with respect to x. Now I integrate. Integral of dv will be the integral of this other side of sine 1/3 x with respect to x. Now I would say now v will be equal to, what is the integral of sine 1/3 x? We can go back to MF19 and you're going to see that when you integrate sine, the sign changes. It goes to negative cos, right? But because this is not just a sine x, this is a sine 1/3 x. So we have to use the reverse chain rule. Reverse chain rule says you integrate the outside without changing the inside. Then you divide by the derivative of the inside. So we integrate the outside, which is sine. You go to the common integrals table. You see what the integral of sine is. Let's see here. Okay, I'm going to go to the common derivatives, the common integrals table, and I go to the integral of sine, right? We've seen it before. Integral of sine is negative cos. So I'm going to say fine. I saw my integral of sine as negative cos, so I'm going to say this is going to be negative cos. So I first integrate the sine part, right? So I'm going to say, sorry for that. First I integrate the sine part. So it's going to be, actually, this was the integral of sine will be now negative cos. Do you change the inside? No, it's still 1/3 x. But then you must divide by the derivative of the inside. The derivative of 1/3 x is 1/3. So you actually get v as negative 3 cos 1/3 x. This is my new v. And I'm done. Now I'm going to say, write the by parts. I'm going to put the by parts formula again. The integral of u dv dx with respect to x is equal to uv is equal to uv minus the integral of v of v du dx with respect to x. Okay, so now I'll say, what is my u? My u is 6x. So I'm going to say integral of 6x times, what is my dv dx? Okay, this is the thing, right? This is the one. So it's 6x sine 1/3 x with respect to x. So it's 6x sine 1/3 x with respect to x. This integral is equal to, what is my u? You remember, you're now saying uv. My u is 6x, so it is going to be 6x times v. What is my v? Negative 3 cos 1/3 x minus the integral of v, which is again negative 3 cos 1/3 x, multiplying du dx. What is du dx? I look for it at 6, multiplying 6, and this is with respect to x. So what am I actually going to have? So this is becoming 6 times negative 3 becomes negative 18x cos 1/3 x. Then this minus becomes plus. Actually, the integral of now is 3 cos. Okay, you actually say 3 by it's again another 18. So it's 18 cos 1/3 x with respect to x. Which this 18 you can put outside. It's a constant. So it's becoming negative 18x cos 1/3 x plus 18, the integral of cos 1/3 x with respect to x. Now, what is this integral? This integral is not a by parts. It's only the integral of cos. We're going to use the reverse chain rule. And the integration of cos, we saw, if we can go and look for it somewhere. We did integrate it before. Okay. The integral of cos 1/3 x, we did integrate it. And what did we get? It was 3 sine 1/3 x. Okay. Because the integral of cos, we start with integrating outside, which is cos will give us sine, and you put sine 1/3 x. Then you're going to divide by the derivative of the inside, which is by 1/3. So here it was, actually, it is going to be plus 18 multiplying, integrating cos, you get sine 1/3 x. Then you divide by the derivative of 1/3 x, which is 1/3. So this now becomes, and this is negative 18x cos 1/3 x. Then here now it becomes plus, so we can now actually say it is negative 18x cos 1/3 x. Then dividing by 1/3 is like multiplying by 3. The 3 will multiply 18, you should get 54. So it becomes by plus 54 sine 1/3 x. We're almost done, okay? Almost done. We have this now, but this is only part of the thing, because he is for this. This is the solution for this part. So we are going to rewrite this guy here, and show that he is equal to this, and then we simplify. So let's do it. The integral of x squared cos 1/3 x. So we're going to say, therefore now we're actually going to skip 2 lines and then say the integral now of x squared cos 1/3 x with respect to x is actually equal to, we take what the solution was, 3x squared sine 1/3 x minus this integral. So it's 3x squared sine 1/3 x. So it is 3x squared sine 1/3 x minus the integral now of this one, which we have done, 6x sine 1/3 x with respect to x. 6x sine 1/3 x with respect to x. So we can say this is just going to be equal to 3x squared sine 1/3 x minus, you open your bracket. What is the integral? The integral is this whole solution. So it will be minus of negative 18x cos 1/3 x plus 54 sine 1/3 x. And now this is what it is. And what are we going to have now? We say this is then going to be equal to 3x squared sine 1/3 x minus becomes plus 18x cos 1/3 x. Then minus of 54 becomes minus 54 sine 1/3 x. Great job. So now what are we going to do now? We are just going to put the bounds, and we say now the integral of x squared cos 1/3 x with respect to x now from 0 to pi will be equal to, you do this whole thing but you put from 0 to pi. So it's 3x squared sine 1/3 x plus 18x cos 1/3 x minus 54 sine 1/3 x, but this is now from 0 to pi. Now, which is just going to be, what are we going to put? We're going to say this is going to be equal to, I'm putting on an additional page, but you shouldn't, okay? I've been skipping lines. Don't, please, just write it neatly. Don't do what I've been doing, skipping lines. You're not going to, so I'll pretend like I'm still on top there and I'm continuing. Now what I'm going to do is, I'm just going to substitute, okay? I'm just going to substitute. So I first substitute pi, then I substitute 0. So this is actually going to be equal to, if we substitute pi, it becomes 3 pi squared. Okay, wherever there's x, it's pi now. 3 pi squared. So you can write to say 3 pi squared times sine 1/3 pi plus 18 pi cos 1/3 pi instead of 1/3 x, then minus 54 sine 1/3 pi. This whole thing will then say minus, now you're putting 0 wherever there is thing, minus 3 by 0 squared sine of 1/3 by 0 plus 18 by 0 cos of 1/3 by 0 is actually 0 minus 54 by sine 1/3 of 0, which is just 0. Okay, and what would you get? This whole thing will be zeros, because 18 by 0 is 0 times this cos will be 0. Sine 0 is actually a 0, so you don't even need to multiply. So 54 by 0 is a 0. 3 by 0 is 0, which multiplies this, it'd still be a 0, so it will be 0. So it's going to be minus, there will be 3 pi squared. Then now we actually want to know, what is sine 1/3 pi? Well, here is the thing. I'm going to punch it in the calculator. I should make sure my calculator is in radian mode, which I see mine is already in radian mode. When you're punching these pi's, your calculator should be in radians. Anyway, now what we're going to do again is we want to know what are the exact values. I want you to know that we have special angles, and special angles can give us these answers, 0.866 whatever, and then 0.7071, and then it will give you, what is the other answer? Yeah, these two mainly, and then it will give you 0.5, and then it will give you 0 and 1. So if it gives you a 1, you keep it as a 1. If it gives you 0.5, you change it to a half. We want exact things. If it gives you 0.7071, it's the root 2 over 2. Then 0.x is actually root 3 over 2. Then this other one is 0. So there is root 3 over 2, root 2 over 2, half, and 1. So anyway, root 2 over 2 is the 0.7071. It is actually sometimes also written as 1 over root 2. Root 2 over 2 is also 1 over root 2. It's the same thing. 0.86 is just root 3 over 2. We always put root 2. So now if I say sine 1/3, I'm solving the top there. I see the bottom, this whole thing will be 0. But if I say sine 1/3 pi, let's try here. Sine of pi over 3. So I second function pi over 3. I'll get 0.866, which is obviously root 3 over 2. Then I now say plus now, this is 18 pi, then cos 1/3 pi. So let's do that. What's cos of pi over 3? Second function, pi over 3. What do I get? 0.5. So this is going to be half. Then I say minus 54 times sine pi over 3, we've already seen to be root 3 over 2. Now what am I going to do? I just say all this minus 0. So I'm going to simplify this. This becomes 3 pi squared, blah, blah, blah. So it becomes 3, okay? The same thing. It's 3 pi squared times root 3 over 2. So now we are just going to simplify. That's the whole thing. Now when you simplify, you always put numbers before the pi squared. So 3 is a whole number. It will multiply the fraction. It will always go to the top. So it becomes 3 root 3 over 2 of pi squared plus 2 times 18 becomes 9 of pi minus this becomes 2 into 54. It should be 27, right? So minus 27 root 3. This minus 0, which is just like this. So here's your final solution. It should be this. Here's your final solution, and you would be done. That's what you do. And this question is over. We're going to go to the next one. Goodbye. We meet in the next one.